Okay, today we're going to look at segments, their midpoints, and their endpoints. So don't forget from previous classes when you've done some basic geometry, a segment is anything that has a starting point and a stopping point. It has two endpoints. You've probably also heard them mentioned as line segments because they are a segment or a portion of a line. A line keeps going on forever and ever in two opposite directions. It will never stop. So we can't actually measure a line, but we can measure a segment and we can measure the distance, how far that midpoint is and where it is compared to our two endpoints. So some definitions. Our midpoint is always going to be, or the midpoint of a segment is going to be the point. Well, think about where it is. Midpoint sounds a lot like the word middle. So it's in the middle of a segment. To get a little bit more mathematical, we can call it equidistant from the endpoints of that segment. So equidistant, equal distance. If you have two endpoints and a midpoint, well, if that point is right smack in the middle, it's going to be the same distance to one endpoint that it is to the other endpoint. The midpoint also divides a segment into congruent parts that have equal measures. So the words congruent and equal, again, they mean very similar things. Congruent, we're talking about, I have this whole object and I know it's exactly the same size as something else. But if we're referring to a measure like 20 centimeters or 2 feet or 3 miles or something like that, then we usually talk about an equal measure versus a congruent object. But honestly, if you're talking to anybody who's taken mathematics, those terms, you could use them almost interchangeably, and anyone who's taken that subject will understand you. Just formally, congruent when you're referring to the whole part, equal when you're referring to the measure. Okay, so just like distance formula, we actually have a formula that we can use to find the midpoint if we're given 2 points that we can plot on a coordinate plane. So think before I put the formula down, if you're looking for the middle of 2 points, didn't you do something like that in statistics? So you found the mean or the average, and if you're going to find the average between two numbers, what math do you have to do with them? Okay, usually when you find an average, you add the numbers up and divide by how many you have. So if you find the average between two values, you would add them up and divide by 2. And that's exactly what we do in our formula. So our equation is going to be that the midpoint is, you're going to take your x values, and notice I'm using x1 and x2 kind of like we did with distance formula, and I divide those numbers by 2. I do exactly the same thing with the y's, because really, if you take it down to the mathematical reason behind it, we're looking for, if we have x1 and x2, we're looking for how far in between in the x direction, and how far between y1 and y2, how far in between them in the y direction, so we can find the average. So I put a diagram together if that helps you out with organizing. We have point A is at x1, y1, point B is at x2, y2, and our midpoint, which I called M, we find those coordinates by doing x1 plus x2, add them up, y1 plus y2, add them up, divide both by 2. Keep in mind, your x coordinate is always the first value, your y coordinate is always the second value. And when you're doing your midpoint, you are only adding your x's together and you are only adding your y's together. Don't mix and match them. So, a couple examples. Here we go. Example 1, let's find the midpoint between A and B. So our midpoint, again, let's go making sure we're very specific on our labeling. Again, you don't have to label, but it is a really good thing to help you stay organized. So our midpoint, again, never a bad idea to write the formula out the first few times you're working it. And we have y1 plus y2 over 2. And again, just like distance formula, I'm just going to plug my numbers in and see what happens. So I have 0 plus 12, my x's. And my y's, I have 0 plus 8 divided by 2. Again, always make sure you're writing the parentheses on the outside. We're going to be stating another point on a graph, an XY coordinate. And the way we know it's an XY coordinate is by always having those parentheses around that pair of numbers. So then just simplify. 0 plus 12 is just 12. 0 plus 8 is 8. And then if I divide those out, 12 divided by 2 is 6, and 8 divided by 2 is 4. So that is our midpoint. Alrighty, let's look at our second example. So we're looking for the midpoint between E and F. So an x1, y1, x2, y2, good reminder. And then we just start plugging in. So our midpoint, again, add your x's. So that's negative 11 plus negative 19 over 2. Add your y's. 2 plus 6 divided by 2. I never try to simplify in this first step. I want to make sure I get everything organized. I want to make sure I take care of all my negative signs. And if you try to do too many steps at one time, invariably you will have some math typos, even if it's just a simple one, and that can throw your whole answer off. So negative 11 plus a negative 19, it's really negative 11 minus 19. So we are looking at, let's see, just to double check. So minus 19, we are looking at negative 30. Again, never a bad idea to check your math on your calculator, especially if you know you're not quite awake yet. Okay, 2 plus 6 gives me an 8 divided by 2. So then negative 30 divided by 2 gives me a negative 15. 8 divided by 2 is 4. There's our midpoint. Okay, go ahead, pause the video and try out number 3. Okay, to check your work for number 3, and x1, y1, x2, y2, equals 11 plus a negative 9, negative 2 plus 13. Again, do be very careful. When you were doing distance formula, you subtracted your values. When you're doing midpoint formula, or when you're doing an average, you always add your values. So double check, are you doing the correct operation on your x's and your y's? Okay, 11 plus negative 9, aka 11 minus 9, we're looking at 2. Negative 2 plus 13 will give us an 11. Then we simplify that out. 2 divided by 2 gives us a 1. 11 divided by 2, I could leave this two ways. So I could leave this as 11 divided by 2. But if I'm graphing this on a set of coordinates, I don't really know where 11 over 2 goes. So I always like to simplify it out to a decimal value. In other words, we're looking at 5.5, and that's a lot easier to estimate on the graph. All right, so there's our midpoint problems. And again, pause if you need to double check your work or try these out again on your own. Our next piece is, well, what happens if they give us an endpoint and a midpoint, and we have to find the leftover endpoint? So there's 3 ways that we could actually do this. So method 1, we could actually take our formula for midpoint, throw everything in there, and then solve out the resultant equations. Now, I'm definitely going to show you how to do this, but this isn't necessarily the recommended method. It's easy to get bogged down in the algebra on this. So method number 2, we can actually draw this out on a set of coordinates and see if we can kind of count out the horizontal and vertical distances and figure it out that way. And again, there's good pieces and bad pieces. If you have points that are pretty close together, then that's a pretty good method. If you have points that are really far apart, though, you'd need a really large graph, or it might be easy to count incorrectly in between your parts. So I wouldn't necessarily rely on that. And so then the third method, and actually I flip-flop my methods. The third way you can do this is actually listed as method 2, is we're actually going to map out the segments. And this is usually how I approach the problems, but it's not the way you have to do it. But I would definitely try this out either with using the formula or just mapping it out on a segment. And you'll see why in a second why I suggest mapping it out on a segment. So on the back page of your printable notes, if you printed those out, So I have 3 examples here. And so we're going to try one of each method just so you can see how they would be approached. And I'm looking at my values. Number 1, I'm looking at points like 12, 8, and 6, 12. And you'll notice I gave you a bigger graph on here. But this is one that I probably wouldn't use a graph on, because this is definitely going to be a little harder to find. So let's do this one with a formula, and you'll see why I might not recommend doing this every time. So our midpoint formula to write them out. So midpoint is equal to x1 plus x2 over 2, y1 plus y2 over 2. And we were given our values for our midpoint. A is one endpoint, so I'm going to label that as x1, y1, but I am not going to label midpoint as anything because I actually have a spot in my equation already. So I'm going to write in 6, 12 for my midpoint and then fill in my equation. So x1 is 12. I don't know an x2, so I'm just going to leave it as an x. And then my y, oops, that's my x1, y1. So my y1 is 8. But again, I don't know what my other y value is yet, so I'm just going to call that y. Now here's where we're actually going to split this up. So you probably haven't seen an equation like this before, but think about the fact that 6 is in your x spot, but so is 12 plus x over 2. So what I'm going to actually do is, there we go. What I'm actually going to do is take the 6 and the 12 plus x over 2, and I'm going to make an equation just with those. And so now we're going to use some of our algebra to solve out 6 equals 12 plus x over 2. I don't like that divide by 2. But think about how I just said that. The right-hand side of the equation, I'm dividing by 2. What's the opposite of divide by 2? So the opposite is to multiply by 2. So I'm actually going to multiply both sides by 2, and that is going to clear out my equation on the right-hand side and leave it as just 12 plus x. And on the left-hand side, I'll have 2 times 6 is 12. And you're noticing too, I'm almost like running out of room on here. There's not a whole lot of room, but I can just barely fit my last line. I would have to do what to get the x by himself? Subtract both sides by x, excuse me, by 12, and 12 minus 12 is 0. So then let's try this as well with our y value and our y equation. So same thing, I'm going to set these two pieces equal. So 12 equals 8 plus y over 2. I'm going to use the same trick, multiply both sides by 2 to clear out my fraction. And so that clears out. Oops, I accidentally hit the wrong button. Let me pause real quick and let me open that file again. Okay, sorry about that. So we have that back open again. I'm going to have to rework that real quick. So go through, double check, make sure you have everything written down properly. Okay, I'm going to multiply both sides by 2 to clear my fraction. So then simplify that out. We've got a 24 equals 8 plus y. And then I'm going to subtract 8 from both sides. 24 minus 8 is going to give us 16. So our final equation on this, our x coordinate came out as 0, and our y coordinate came out as 16. And that is our midpoint. Alrighty, that's a very involved process to go through to find a midpoint. So I'm actually going to show you, let me show you this on the same value, and we can use this as checking our work. It's never a bad idea to use if you know 2 different methods to do a problem. That is a great way to check to see, hey, did I agree with my answer? Did I do this problem correctly? Okay, so here is the mapping version of this problem. So I know I'm finding midpoints, so I'm going to draw a segment that has a midpoint. So my midpoint is in between segments A and B. I was given 12, 8 as my first point. My midpoint is 6, 12, but I don't know what my endpoint is. So I'm just going to leave an empty space here to help me know where I'm going with this. Okay, here we go. To get from 6 to 12, excuse me, to get from 12 to 6, imagine your number chart. What do you have to do? So to get from 12 down to 6, I need to subtract 6. So to get to my other endpoint, I'm going to do the same thing. What's 6 minus 6? Well, it's 0. Okay. Do that again with your y's. To get from 8 to 12, what do you have to do? Imagine your number line. So 8 up to 12, you have to add 4. So do it again. What's 12 plus 4? 16. And lo and behold, we found exactly the same set of coordinates a whole lot quicker. Now, you have to be careful with counting. You have to think in the same direction going all through the problem. But this is a much quicker way into looking at where's your missing endpoint. So let's try this with number 2. So I know there's fractions on this one, but we can still use this kind of mapping technique to figure out where everything is. So again, I'm going to do same color coding as we did before. I'm going to draw my segment and my midpoint. I'm going to give myself a little bit more room on this one. So we have point A, point M, point B. Point A is at -3, -4. Point M is at -1/2, -1/2. And I'm trying to figure out what point B is. So this one, we want to be very careful about thinking where we are between these points because we're dealing with a fraction on this one. So be careful on your math. Okay, here we go. So -3 to -1/2. Imagine your number line. So -3 up to -2, up to -1. So I've gone 2. Up to -1/2, I need to go another half. So I am actually adding 2.5 or 2.5. So what do I have to do to get to endpoint B? I need to do the same thing. So plus 2.5. So what's -1/2 plus 2.5? +2. Okay, so now let's do our y values. So we have -4 up to -1/2. What do you have to add? Again, -4 is further down on your number line. What do you have to add to -4 to get it up to -1/2? Well, we got all the way up to 0, that'd be 4, so only halfway back. We're going to add 3.5. So again, I have to do the same thing to find my y value. So plus 3.5 or 3.5. So what's 3.5 or plus 3.5 minus 1/2? We're at the point 2,3. And so with this one, I'm going to go ahead and check this on my graph. These are smaller points, a little easier to deal with. Let me go back to red ink so it'll pop better on the graph. Okay, so we have a point A at -3, -4. So -3, -4. There's our A, -3, -4. We have a midpoint at -1/2, -1/2. So -1/2, -1/2. It's actually sitting right smack in the middle. There's M, -1/2, -1/2. Okay, so I have to go right 2.5 and up 3.5. So go right 2.5 and up 3.5. And there's our extra endpoint at 2, 3. There's point B, perfectly evenly spaced all along the segment. Okay, go ahead and pause the video and try out number 3 using any method. Again, my suggestion is pick 2 methods and then see which one works best for you. It's always a good idea to use that second method to check again. So again, pause the video and try out number 3. Okay, so let's check how you did on number 3. So again, I'm going to go for that middle method for mapping it out. So I'm going to pick a darker color. Here we go. So point A, point M, point B. So A, M, B. A is 2, 0. Midpoint is 5, -2. The other nice thing about doing this method is you really have to think about where you're putting your points. Always stop and think, are they giving you 2 endpoints or are they giving you a midpoint? Okay, map it out. 2 to 5 is +3, so I need to add another 3. I get to 8. 0 to -2, I'm subtracting 2. Subtract 2 again. -2 minus 2 gives me -4. So my solution, whichever method you picked, should be 8, -4. Alrighty, so there's 2 more practice problems on here. I would absolutely suggest trying these out. And then what I'll do is I'll post the finished version of this. If you pull that up on the completed organizer, you can go through and check your work. Let me know if you have questions.